Hi everyone, it's me again, your virtual teacher. And today we will have a part 2 of our work related algebra problems. Are you ready? Let's begin. In the previous video, we solved the work problems in a traditional approach of expressing the work rate as a portion of the work agent per unit of time. As shown in this formula, 1 over t sub b is equal to 1 over t sub 1 plus 1 over t sub 2 up to 1 over t sub n. This formula is easy to use for less work agent involved, but as the number of work agent increases, it will become tricky and confusing. Today, we will introduce you to the man hours or man days concept. This is more powerful technique in dealing with a large portion of time and work problems. Let's start. Problem number 1. It is known that a particular project can be completed by 9 employees working 8 hours a day for 25 days. To speed completion of the project in a particular town, the supervisor is being provided with 12 workers and is being asked to complete the project in 15 days. How many hours a day must the employees work each day to finish on time? Solution. First, we will compute the total amount of work to complete the project from the initial number of 9 employees. So, 9 men times 8 hours per day times 25 days is equal to 1,800 man hours. Assuming y is equal to the unknown hours a day to finish the project in 15 days with 12 workers, we have 12 men times y hours times 15 days is equal to 1,800 man hours. Rearranging, we will have y hours per day is equal to 1,800 man hours divided by 12 men times 15 days, which is equal to 1,800 hours per 180 days, or is equal to 10 hours per day. Therefore, the man should work 10 hours per day in 15 days to complete the job. Problem number 2. A work can be completed by 12 men in 24 days and 12 women in 12 days. In how many days would the 12 men and 12 women working together to complete the work? Solution. Since there are two groups of work agent involved, we will solve each work agent's total amount of work. The amount of work for men is equal to 12 men times 24 days, which is equal to 288 man days, and the amount of work for women is equal to 12 women times 12 days, which is equal to 144 woman days. Since both men and women is doing the same work, we can safely equate the amount of work for men and the amount of work for women. Therefore, 144 woman days is equal to 288 man days, or 1 woman day is equal to 2 man days. That is our relation number 1. Working together from the relation 1, we have 12 men plus 12 women is equivalent to 12 men plus 24 men, which is equal to 36 men. Since the total work or amount of work for men is 288 man days, we can now obtain the total days if 12 men and 12 women work together. That is 288 man days divided by 36 men is equal to 8 days. Therefore, if they work together, we can complete the job in 8 days. We can verify this by using the amount of work for women. So we will have 12 men plus 12 women is equal to 6 women plus 12 women. This is from the relation number 1. Therefore, we have 18 women in total. Using the total amount of work done by women alone or women group, we will have 144 woman days divided by 18 women, which is equal to 8 days. Same result when we use the amount of work by men. Problem number 3. In 25 days, 25 men can complete a work, but instead of working together to finish the job, 5 men left every 10th day. In how many days would then the work be completed? Solution. First, we will compute the total work amount to complete the work. 25 men times 25 days is equal to 625 man days. But since 5 men left every 10th day, we will compute the amount of work every 10 days. So from 1st to 10th day, there are 25 men times 10 days is equal to 250 man days. In the 11th to 20th day, the amount of work will be is 20 men times 10 days, 20 because 5 men left, plus the 250 man days from the 1st to 10th day. This is equal to 450 man days. From 21st to 30th day, there will be 15 men left times 10 days plus 450 man days from the 11th to 20th day, and this is equal to 600 man days. From the above equation, from 21st to 30th day, we can see that only 25 man days are needed in order to complete the job. So, we will expect that the job will be completed in 30 plus days with 10 men left. Therefore, 25 man days divided by 10 men plus 30 days is equal to 32.5 days. Therefore, the job will be completed in 32.5 days after 5 men left every 10th day. Problem number 4. 20 men can cut 30 trees in 4 hours. If 4 men leave the job, how many trees will be cut in 6 hours? Solution. First, we will compute the total work done by 20 men in 4 hours, which is equal to 80 man hours, assuming that each man has the same ability. So we can compute the trees cut per man hour, which is equal to 30 trees divided by 80 man hours, or is equal to 3 trees per 8 man hour. This is the work rate per man. If 4 men leave, the total work will become 16 men times 6 hours, which is equal to 96 man hours. This is the new work rate after 4 men leave. Therefore, the numbers of trees, these 16 men can be cut in 6 hours, are using the amount of work from the 16 men, which is 96 man hours, times the rate of every man, which is 3 trees over 8 man hour. This is equal to 36 trees. Therefore, 36 trees can be cut by 16 men in 6 hours. That's all for today. Hope you learned something. And once again, see you next time.